Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating application of linear programming. Optimizing item builds in League of Legends for the champion Kai'Sa. It's a surprisingly complex problem.
I'm hooked already. So how does linear programming help with something as seemingly chaotic as building a champion in a MOBA? I mean, there are so many variables.
Exactly. The core idea is to define a cost function, in this case, the total gold cost of the items, and then set constraints based on Kai'Sa's passive. Her abilities evolve when she reaches certain thresholds in attack damage, AD, ability power, AP, and attack speed, AS. We use linear programming to find the cheapest combination of items that meets those thresholds.
Okay, I see. So we're minimizing the cost function, gold, subject to constraints, stat thresholds. But isn't it more complicated than just that? I mean, League of Legends has hundreds of items.
You're right, it's not quite that simple. The author cleverly uses the Data Dragon API to fetch item data directly from Riot Games, avoiding manual data entry. This API provides all the necessary stats for each item. Then, a crucial step is filtering out items that aren't purchasable or aren't relevant to Kai'Sa's build. This reduces the problem to a manageable size.
Smart! So after filtering, what's the next step? How does the actual optimization happen?
The author uses the Rust programming language with the good_LP library and the SCIP solver. This allows for integer linear programming, which is essential because you can't buy fractions of items. The code constructs expressions for the cost function and the stat constraints, and then the solver finds the optimal solution. It's all quite elegant, really.
Elegant indeed. But what about the results? Did they find a truly optimal build? What did the optimal build look like?
The initial optimal build was surprisingly cheap, around 8,300 gold, but it lacked movement speed. This highlights a limitation. The model only considers the stat thresholds for evolution, ignoring other important factors like movement speed, which is crucial for positioning and kiting in League of Legends.
Right, so the purely mathematical optimization isn't perfect for the real-world game. That's interesting. What about adding movement speed as a constraint? Did they try that?
Yes. Adding a movement speed constraint significantly increased the cost, and the resulting build wasn't as efficient as simply buying a dedicated movement speed item separately. They also explored reducing the number of item slots to accommodate a dedicated movement speed item, which yielded a more balanced and practical build.
So the purely mathematical approach needs some human intervention to account for the nuances of the game. That's a really important point. It's not just about numbers, it's about strategy.
Precisely. The article concludes by suggesting further refinements, such as considering the order of ability evolutions and optimizing for late-game scaling. These are more complex problems that might require more advanced techniques than simple linear programming. It's a great example of how mathematical models can inform, but not completely replace, human judgment in complex systems.
Absolutely. A fascinating application of linear programming, and a great reminder that even with powerful tools, human intuition and strategic thinking remain essential. Thanks for breaking this down.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.